Welcome back to my Learning About AI series. Back in October, I did an episode called The No Nonsense Guide to AI, where I broke down some of the main buzzwords being thrown around and used interchangeably for AI, those being artificial intelligence, machine learning, and deep learning. Today's episode is a follow up to that, so if you missed that one, be sure to go listen to it first. But, just as a quick recap, AI is the broad concept used to build intelligent machines. Machine learning, ML, is a subset of AI, where machines learn from data without being explicitly programmed. Deep learning is a subset of machine learning where neural networks mimic the human brain to find patterns and make decisions. Okay, now that we're all caught up, let's dive into the fundamentals of AI. One of the goals, or I should say the main goal, of AI is to create algorithms that mimic human intelligence. There are two main domains: unsupervised learning and reinforcement learning. Let's start off with unsupervised learning. You can think of it like exploring a new city without a map. You just want to wander around, observe landmarks, how streets connect, and see new sights. After a while, you'll start noticing patterns, such as streets being more busy, parks in one place and skyscrapers in another. That's unsupervised learning. This is when the AI algorithm is given data without specific instructions of what to look for, and it's allowed to just explore that data. As it does, it will begin to identify patterns and structures on its own. That's why I compare it to navigating a new city. You don't get told by someone where to start walking, you just wander and start learning by yourself. Now, do you remember how to ride a bike? If you do you remember learning? I do. I was in my backyard trying to ride down the path. It was a lot of trial and error. When I balanced the bike properly and pedaled, the reward was staying upright. If I didn't pedal and I ended up falling over into the grass, that was a penalty. In reinforcement learning, the AI algorithm learns to make decisions by performing actions and receiving feedback in the form of rewards and penalties. If you don't balance yourself properly, just like when you're learning to ride the bike, you'll fall to the side. But if you do, you can ride the bike wherever you want to go. I remember being so proud when I first learned. Started racing down hills without pushing the brakes into the last moment. But don't try that at home. It's a terrible idea. Didn't fall off, but still not a good idea. But just like us, in an almost, I guess you can say, childlike way, the AI learns what actions lead to success and gradually improves its performance that way. Now, you're probably thinking, I thought this was fundamentals. How do I get started in all this stuff? Well, the first thing to start off with is math, specifically statistics. Sorry. Now, I know some of us just groaned in disappointment, but hear me out. All complex algorithms in AI are based on a solid foundation of math. This includes topics like linear algebra, calculus, probability, and more. We want these systems to carry out amazing and complex tasks, and most of them require heavy calculations that we will balk at doing by hand. Unless, of course, you're a super mathematician, but not all of us. But technology really loves and thrives on math. Some would even say that statistics is the backbone of machine learning. Grasping statistical measures and concepts, such as standard deviation and variance, equips you to steer AI systems in interpreting and making sense of data. You'll notice that I keep mentioning data throughout this episode. That's because algorithms need big, preferably ethically sourced, data sets in order to run and be the best they can be. Without the data, they'd be pretty useless. Think of streaming services like Netflix, who use vast data sets to recommend shows based on your viewing history. Okay, once you have the math down, the next step is to get into the programming. Woohoo! This is personally my favorite part. The programming is what really brings the AI to life. Python is the first choice for artificial intelligence because it's easy to understand and has lots of special tools for analyzing data and machine learning. It's a strong language, but also great for beginners, making it really good for putting machine learning ideas into action. But Python isn't the only coding language. R, Java and C++ are commonly used as well. So just in case that kind of went over your head, that's just a lot of words at once, I'm going to break down each one. R is mainly used in data science for its ability to handle statistics and make interesting graphs and charts. It's a bit harder to learn than Python, but for those really interested in diving deep into AI and data science, learning R is a valuable skill. Java is a programming language that offers more control over the smaller, detailed operations of the computer. This is really useful in building large-scale machine learning or AI models. It's a good choice for making complex AI systems that need to be efficient and work on a big scale. C++ is another language that gives you a lot of control over the finer details of how this computer works. This makes it a strong choice for creating AI and machine learning models that need to run fast and handle a lot of data. It's great for building powerful and large AI applications. So, if we focus in on Python, there are a few libraries that you need to know about. You're probably thinking libraries in terms of books, but in programming, a library is You're probably thinking of a library in terms of books, but in computer science, a library is a collection of non-volatile resources that are used by computer programs, usually for software development. This is things like configuring data, documentation, message templates, pre-written code, all that good stuff. So, what are the libraries that you need to know about? Of course, there's probably more, but this is a good starting point, I think. These are Pandas, NumPy, and scikit-learn. Pandas is a tool used in Python for organizing and changing data. It's really good at handling data tables and is very important for anyone working in AI. It helps in arranging data in a way that makes it easier to work with and understand. NumPy is a library in Python, NumPy is a library in Python that's great for doing math with arrays, so basically lists of numbers. It's also useful for tasks like linear algebra, which involves solving equations, and working with matrices, which are like grids of numbers. It's a go-to tool for mathematical operations in Python. Scikit-learn, the last one, is a Python library that brings machine learning to life. It has lots of different tools and algorithms, like vector machines and random forests, which are methods for making predictions or classifying things. It works well with NumPy and another library called SciPy, both of which are used for scientific and numerical computations. This makes scikit-learn a key library for machine learning projects. So, I mentioned that there are some other great libraries, and there's two more I want to talk about. So there's PyTorch and Keras. Hoping I'm pronouncing that properly. PyTorch is a library that's really flexible and fast for building machine learning and deep learning models, especially in the natural language processing side, which is about helping computers understand and work with human language. It's known for letting AI developers experiment and build things quickly, which is great for research and creating complex AI models. Keras is a Python library designed for working with neural networks. So if you remember the deep learning, that's where Keras would come into play, which are a type of AI that mimics how human brains work. It's especially friendly for beginners because it's easy to use and understand. Keras makes it simpler for those new to AI and machine learning to start building their own neural network models. So, I think that if you start with these basic foundations, then you can start specializing. What I would recommend is to think of a project you'd like to do and work backwards from there. Figure out what language and libraries are most commonly used and learn those first. For example, I've given you all these libraries and languages, but let's dive into a hands-on project idea for those of you that might be eager to put your Python skills to the test. So, imagine you have a collection of images, each of them depicting various flowers or animals. So what's your challenge? Create an image classification model that can accurately identify and categorize these images. This is a fantastic way to start exploring machine learning. You'll be using Python, primarily with the help of scikit-learn, for the machine learning algorithms, and NumPy for handling numerical operations. As you embark on this project, you'll learn the basics of machine learning, gain insights on how to process and utilize image data, and understand the foundational steps of building and training an AI model that can distinguish, for example, a rose from a tulip or a dog from a cat. It's fun and engaging to see AI in action right from your computer. Plus, the skills you'll develop here lay the groundwork for more advanced AI projects in the future. I recently went to the science gallery with my friend Hannah, and they had a lot of different interactive displays centered around AI. It was awesome. One of my favorites was called How Not to Get Hit by a Self-Driving Car by Tomokihara and Playful. It was a straight-based game that challenged people to avoid being detected by the self-driving car algorithm. Basically, you wanted to get hit by the imaginary car, which is not something I'd recommend in real life, by the way. It was really fun, and people tried all sorts of things. The lady running it said that she had seen it all that day. We saw one guy put a traffic cone on his head and his arms. He ended up getting detected because I think it saw his legs, but he looked cool. Then two ladies shared a scarf and held it up in a big rectangle to hide themselves. Surprisingly, they didn't get detected. I think one lady ended up bunching herself up in a ball and rolling, and it detected her as a suitcase. It was crazy. This game is a fun, interactive way to understand complex technologies behind real autonomous vehicles. The programming languages and libraries I talked about, like Python, C++, and PyTorch, are not just theoretical concepts, but they're also actively used in the development of such advanced systems. In self-driving cars, Python is often employed for data analysis and machine learning, with PyTorch playing a key role in image recognition. It's crucial for distinguishing between pedestrians, just like the game. Pandas and NumPy come in handy for organizing and processing the large volumes of data these vehicles generate. However, when it comes to the real-time decision-making, basically the actual hard work required in both the game and actual self-driving cars, C++ is the hero due to its speed and efficiency, especially in processing sensor data and controlling the vehicle's movements. Java might find its place in more behind-the-scenes aspects, while Keras, remember that Python library, is perfect for initial neural network designs. So I just wanted to give you this example because I hope it shows you how a mix of technologies, such as the programming languages such as Python and C++, can come together to create not only engaging games, but also safe and intelligent self-driving cars of the future. Whew. I don't know about you, but I think that's a good starting point for us. As a summary, all AI algorithms are based on math. You can't get away, I'm sorry. There are two key domains of how these models learn: unsupervised and reinforced. Unsupervised is like exploring a new city, where you find new patterns on your own, while reinforced is like riding a bike, figuring out through trial and error. We also talked about, unsupervised is like exploring a new city, where you find new patterns on your own, walking down the streets, smelling all the beautiful food, all that good stuff. It helps you to learn. While reinforced learning is kind of like riding a bike and figuring it out through trial and error. We also talked about the different programming languages that are used. Python is probably the most popular, but R, Java, and C++ are used heavily as well. I hope today's episode was helpful in getting you a starting point for how you can get involved in AI. I hope today's episode was helpful in giving you a starting point for getting involved in AI. If you have any questions at all, feel free to PM me, and I'll try to help. Thank you.